How's it going, everyone? Welcome, Euler Gonzalez here, and today let's going to look at the chapter 3 from this book that was written by Kyle Simpson, a software engineer that has previously worked at several startups and companies over the past 20 years, and he find out that a lot of folks, even college, they don't know truly, and they complain a lot of the language design and how the language behave, and because they don't understand how the language, and that to me is quite mind blowing, and because the language doesn't be in, since the language is this script language, which is not that hard, quote quote, as compiled language. Therefore, this language should be is now an easy grasp. But it turns out that the language in itself, which was developed by Brendan H., is behave in a particular way that it might be counterintuitive to those who come from backgrounds like Java or C or C++, right? And because of that, now instead of understanding how the things work, they blame to the language of their poorly designed. So this is the motivation, or the in my case, the 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 suffering any times that I try to use one of these particularly operators or tools in the language, uh, that I don't truly know what's going on, and therefore now and then I mumble, right? It's a it's like, what are you doing? What are you saying? When you're trying to explain that, it's like all of your words crossovers. It's a battlefield, so you're confused. Is because you don't know how the things work. And the thing here is, there is a spec that you can follow and understand that. So, but in any case, this chapter 3 actually makes emphasis of looking at and understanding it in chapter 1 and chapter 2. And I'm going to make a quick recap of chapter 2 and 1, where in chapter 1, we look at, hey, what is JavaScript? Who made JavaScript? Why the name JavaScript? And who oversees the technical aspect of JavaScript, right? Which is the TC39. Who owns the legal trademark, which is Oracle? And who is this Oracle, briefly, right? And who is this TC39? What is the goal? What is the purpose of this, right? And how now the TC39, despite that they promote and oversee is that the JavaScript doesn't break the web, well, a lot of the time it is quite hard to do so, because despite that the members of this board, this room, are now or coming from different of this web related industry, whether it's browser makers or device maker like Samsung, right? So it is quite hard to understand the reality of the web. This is a special tragic dramatic comedy event that happens in JavaScript community, where it is known as the Mushgate, where the reality is that is related huge to what JavaScript developers are getting to when they have this diversion, or this idea of how the things supposed to work, where of the how JavaScript actually works. And when there is a diversion, or when there is a when the mind of the developers now diverge from what JavaScript is, that's when a lot of the time a bug is introduced, which is something that Kyle Simpson actually mentioned. Now, when it comes to now provide is and guarantee that the web doesn't break, one of the things is by providing is polyfill. So what is a polyfill? What it stands for, and because you can now run is JavaScript in several environments, whether it is on the browser, on the server, light bulbs, IoT, robots, right? Each one of those environments expose certain APIs that you can work with. But the only reality is that the web is the only thing that matters. And for those who cannot, for example, JavaScript implementations, for those who cannot follow is the guidelines or the standard, there is a specific appendix on the docs. Why is this? Because those JavaScript implementations refuse to implement those or certain features due to legacy reasons, for example. However, despite that the spec might say something, the way of how they implement and the timeline varies across browsers or JavaScript engines. So, but in any case, we also looked at how can we use now JavaScript, for example, to write programs in a functional, object programming, and procedural. And when it comes to understanding now how JavaScript works, especially JavaScript, not all JavaScript environments are strict JavaScript environments. For example, the dev tool, the console in the dev tool, and we're gonna see that why. But it is also important to understand that JavaScript is a compiled language. Okay, the TLDR is that yes, if Essence is not in practice, JavaScript is a compiled language because the way of how it evaluates certain errors, and there is now a particularly syntax semantics in some of these features that we have in JavaScript, for example, var or functions declarations, and among others, that it performed these early errors. And because JavaScript is a compiled language, so you have now this parse and execution phase, and the concern was to say, hey, how if JavaScript is fast enough to run now, for example, applications like in C. So ASG was a set of precedents that is possible by actually pour a Unreal game into the browser, and since this is a subset of JavaScript, it provides now some hints to the JavaScript engines to do optimizations and allow to run them. So the spiritual successor, which is WASP, is say, hey, let's going to take a little bit further of ASM, and instead of parsing, or instead of worrying about the parsing phase, it's going to skip that by providing us an intermediate representation of a language like an assembly, and therefore we're going to now only focus on the execution of the code. So this WebAssembly or WASP becomes now a universal compiler target. The scope of this is not about that. It's more about talking about the language as well as the strict mode, that this is just a set of guidelines that developers must do to provide good hints to the JavaScript engines to do optimizations and executing your code in the most performant way possible. So this strict mode is this guidelines, all right, that tells the best way to do things for that chance to JavaScript to get the chance of JavaScript of optimizing and executing your code. Now, this is chapter 1, and in chapter 2 we look is a little bit of the JavaScript, serving JavaScript, as he mentioned. So this is, hey, what is a program? How JavaScript see a programs, and what can we have in programs? So for example, is values, what a value is, which is the most important unit of information, what this information or values looks like, which is primitive and objects, and what can we use these values to actually manage is the state of the programs. right? And because of this, we have different way of representing values in our programs for ourselves as users or as a developers, right? So for example, we have now is a string and number that each one of them following a specific uh, guidelines or standards, right? So string follows the Unicode, numbers the IEEE 7054, the Boolean as well, which is true and false, the symbol, which is for storing its hidden properties, the bigint for now representing its long numbers that numbers fell short, all right, due the accuracy, and this go beyond the scope of today's videos, but the other is the kind of emptiness, like null and undefined, and why we prefer to go with undefined rather than null, because it have a particular edge case, and also the way of how you can represent now is other data structure like objects. All right, so for example, a collections of elements, right, in this numerically indexed sequence, when you have now is all of these possible values, primitive values, arrays, objects, which is a key map, right? You can think of these objects like a table with two columns, right? Where now the first is the key to identify that, and the second is where the value, and this second column can sometimes spread or not, all right? And now functions. And I hit the brake on functions because this is something that is quite counterintuitive, and a lot of those courses out there, they say that functions in JavaScript is the first class citizens. I think that it's just a way to obfuscate what it really means. It means that functions are values, and functions is a special kind of objects, right? And this is all about. That's it. And you might wonder, okay, so if this is a value, what can we do with this value, right? What can we represent with this value? Well, functions can represent is now sequence of instructions. So the way how these values can be represented in the language is through literals, all right, or by holding them into a variable, into a container. So this container that depend on the syntax form, it can be is a depend on the syntax form, right? Depend on the syntax form, it can be is a var, a let, and a cons. So what does a var, what does a let, what does a cons, what is the constraint about where they can be applied? And also is that because we can now hold we can now define variables like that, these containers. Another way to define a container is in a functions declarations, right? So we can have, and this makes a lot of sense, and this makes a lot of sense. Yeah, and it's quite silly, but it is. it is. You can say, hey, print value, right? And because this association, okay, let's say now value, okay, and because this association, print value here, hello world. All right, so this association here, all right, between the functions this association of the identifier and the value happen is at parse time, in contrast of the function expression. And these two concepts are very important because it will lay out the way of how can we use these particular tools, the declaration and the expressions, when do we define them and when we actually use the value or when we produce the value, right? And in this case, we also look at how can we define as variables. So for example, inside of a functions, like in this case with value inside of this is another way. And we try and catch, when we catch is the error. So because with functions here, we also looked at how functions behave. And that is in JavaScript, it has a broad meaning. So it can be a procedural or a mathematical definition of what a function is. And a procedure is that you define it as a set of instructions that can be run once or several times. So for example, configurations you only run once when you initialize your app, okay? And you may provide some inputs or may return some outputs, one or multiple outputs, all right? And with functions, it say, hey, no, you have to follow is a strict set of rules that guarantees some properties, all right? This is known as, for example, this is from functional programming, for example, referential transparency and pure function, which is just a way to guarantee that that function, when it's called, it doesn't alter the state of the application in an unexpected way. All right. So again, this goes beyond the scope of today's video, but this is the two way of how can we use now functions here, and when it comes to determine what is the value of a type, all right, or type assertion value, all right, whether it's in a primitive or in an object, it is important for us to understand that function is a value, as I mentioned before, in not arrays. And there are no particular way of how you can determine that. But this is because the way how the language actually works, right? So for example, with primitive like null, it returns an object, but with primitive like function, it returns now a function, right? Or in this case, an object. If this is an object, it say, hey, this is an object. If this is an array, hey, this is an array. And this is just to describe what is the true values of JavaScript, right? So if this is a string, this is a number, this is a string, if this is a boolean, right? If this is an undefined, right? If this is a big int, right? It tells you that even though that this is a number, even infinite is a number, nan is a number, all right? And the idea is that once we're able to look and understand what that a function can be used now in the values, in any values that can represent this set of instructions, right? It opened up now a new paradigm, which is the functional programming and its pattern. So, because we also look at how can we organize our code, right? Whether it's by class or by a model. And when it comes to a class, it's to say, hey, this, the class is this. So the class is a declaration of a custom type of a data structure that contains data and its behaviors to operate, or that can operate on that data, right? So this is the formal definition of class, and how can we use now class here in the language, and why it is important for us to create a new instance of this class using the new keyword, all right? And this is one way to organize our code. And the other is from models. whether it's using a function approach, all right? When I'm going to encapsulate is the data and its functionality in a function, and expose is only those that are relevant, all right? So for example, the methods here, and when it comes to now or acquire the property of the methods here, in class we use extends, and with functions we use now the prototype, all right, to actually is inherit all of those functionality from other models, okay. In using now the EX6 models, here we have is the way of how can we import, and by importing using the import and export. But first is when you want to now expose certain properties, you want to make it then public, you export it, and if you don't, you just define them in that file. So each file is now a model. So this way of organizing the code is just to understand, or it's just to serve in JavaScript. Okay, so how JavaScript which a programs, what a program is, and what now a program allows to do, which is represent and manages values, what a value is, which is here is the way how can we represent this information. For example, you have now a primitive and objects. We also look at what are the spec that certain primitive follows, also the objects as well, and how now in objects we have is this different way of how can we represent a value here, whether it's an array or an object or a function, and how now can we use these values, whether it's a literal or a or held into a variable, aka a container, and this container has a syntax form that varies across or that has inherent properties. So for example, var, let, and const, and how they behave, and how can we also define these variables using now is the function's definition, and this association between the identifier and the function's body and the value happen is at parse time, whereas in function expression this association happens is at runtime, okay. And how can we also define these variables or container inside of our functions here as parameters, the try and catch as well, all right. And when it comes to look at functions, how can we use a function as a procedure or a mathematical definition of a function, okay? And how these functions can be using variables like a function expressions, and in another type of values like objects and functions. And then how can we now is organize all of this set of instructions, organize our code, whether it's by using class and inherent property or getting access to those property from this superclass or this base class via the extend, okay, or when it comes to define is the models, right? Whether it's by functions and like whether it's by functions, when you only expose is the public API, all right? Whether it's immediately in both function expressions or functions, right? Or by models, whether it's by exporting is the variables that you want to, and those that you want to hold private, you don't, all right? And the difference between the models and the class is that in the class you need to create that, you need to instantiate that via the new keyword, where in functions or in model you don't have to do that. So here we are now to look is at digging into the root of JavaScript, which is exploring is now these low level features in JavaScript to get the feeling of JavaScript and how it ebbs and flows, right? And I do, and one of them is the iteration. In fact, there are several of them. You know, we have the iteration. We also have is the consuming iterators, right? We're also going to talk about the iterables, as well as the closure, okay, and the this keyword, but and the prototypes, okay. So as we read about this, for example, in the iteration. So yesterday we looked at the iteration as yesterday I look at iteration to understand is why we have this particular patterns when it comes to produce or consume now data, right? Because most programs at the end of the day they serve to process data and to make decisions on that. So the pattern is used to step through the data, have a big impact on the program's readability. It is so the way of the pattern of how you go through the data has a big impact on the program's readability. So the iterator pattern, which is something that is not new and it has from decades in programming, okay, suggests a standardized ways to consume data from a data source, okay. So consuming data from a source, from a data source, okay, and this data source emit those one chunk at a time, right? So the idea is that is the more the idea is that it is more useful to use a particular data or to use a particular pattern to iterate on that data source progressively, okay, by taking the first part of the data and this the next and so on, rather than handling the entire set all at once. And this is also for memory consumption here. So you can imagine is, for example, if somebody actually throw you this particular book, if you're reading a book or a paper, right, or a tweet, okay, if you're reading tweets just for the sake of reading, you will never understand what's going on in this entire pile of excrement or this entire pile of flame words that happen in Twitter, right? So so because of that, all right, and since here is where the eyeballs are, the point is that we want to navigate some way of how can we consume this data and digest it properly, each chunk at a time, all right? So you define is a particular pattern or a particular conduct, a behavior here, all right? So this iterator, I do think that they belong iterator pattern, right? Exactly. It's part of the behavioral pattern. It makes a lot of sense. It makes a lot of sense. So this is the behavior here. Mm-hmm. Mm-hmm. Well, this is real world analogies here. So, for example, is this So for example is this, right? And this is how you can implement that, right? But the point is that this iterator, right, has a reference of the underlying data source and is going to, so this, the iterator pattern describe that. The iterator pattern describe is this standardized ways to process data from a data source, each one at a time, because most of the time, so programs are meant to process is data, or are meant to build, so where they're essentially built to process data and make decisions on that data. So because this, the pattern that you use to process that data has a big impact on the program's readability. So this iteration standard, okay, or this pattern is a standard way to say, hey, if you want to consume data from this data source in order to process that, but if you want to consume this data, we're going to get that one chunk at a time, all right? And this is the most helpful way to do that, by defining is a data structure that have a reference to the underlying data source, and expose is the expose is the element one at a time via the next function call, right? So this next function call is like calling is rows in a database. You can think of this, right? So calling rows in a database, and you don't always know how many pieces of data that you will need to iterate through. So this pattern is quite useful, especially when you don't know is the underlying data source, but you know that there is an end. So the importance of the iterator pattern is that adhering to a standard way of processing data iteratively, which create cleaner and easy to understand code, as opposed to having every data structure or source defining its own custom way of handling its data. So that's this custom way of defining things, at least for scalability. This is one of the reasons why the MCP protocol was created, is because you have a nightmare. You have a constellation of servers that this agent wants to consume. So because all of this has particular way of API and so on and so forth, so it create now a protocol on that. And this protocol stuff here, I do think that this is where the value it will be, right? Because for example, when you define is a protocol, when you define a standard ways to do things, most of the times this speed up things, right? And people now can jump in and work and collaborate and to make money out of this. This is why the NCP protocol actually called my attention, because similar to the precursor of internet, which is the network control protocol, where the idea is to say how can we now control is the network, all right? How can we now control is the network scalability, how the network grows, and they realize quickly that trying to control the network is quite hard, all right? People at DARPA realize that, and so it's quite hard. So they say, hey, instead of trying to control the network, let's go to control now how the communication happens. And this is why the internet protocol or the TCP actually makes a huge impact on that and provide, of course, a lot of jobs and so on top of that and so on and so forth, right? But I do think it's based on this protocol. It's an open standard protocol introduced by Anthropic, designed to standardize how AI applications such as chatbots, idea assisting, and custom agents connect with external tools. Data source, the data source that we're talking about here. So this data source can be is whether it's a database or a document or any other type of data source, uh, in systems, right? So not only to connect is to data sources, all right, but also is to connect to systems. So for example, is well the the service that provide Google or AWS or Azure, okay? So is that how they can connect to any of these data sources? Mm. Or you can connect to any of these data sources or system. Interesting. But I do think that it is the ability to feed this kind of project here. Yeah, absolutely, absolutely. Is the ability to go and do that. Hmm. Oh, MCP course. Mm-hmm. 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 I do think this is something that I want to dedicate time later on. All right. But why this is translated? No, I don't. I want to get this on the original. Original, bro. Original. Mm-hmm. Okay, makes a lot of sense. Mm-hmm. Mm-hmm. Why you're translating this? No, I don't want you to translate that. Oh my god. You're gonna do that, right? Yeah, because anyway, but that's not what I want. So, but as you can see here, is this particularly patterns, right? This particularly problem that is solved, that aims to solve, and it is like how can we consume now this large amount of data, all right, in a way that is easy to go, easy to do that, easy to maintain, and easy to read about this. Okay, so uh, so the iterator patterns describe in this case something that we can take a look at the ECMAScript. It is well, I'm going to have is a reference of the data source, all right, and if this data source uh, I'm going exactly. I'm going to describe is a data structure that have a reference to the underlying data source, all right, and then I'm going to expose is the searching methods. The next that here is when you have now as a function, and here's when you're going to have is this value, all right, when you call it, okay, uh, and you can continue to call that until and here going to produce now is the value, and if it's done, and you're gonna continue to call that until the value done is true, right? So when it comes to consume iterators here, right? those data sources that implements now is the iterator protocol, right? So with EX6, the EX6 iteration protocol in place, it is a workable to consume a data source one value at a time, checking after each next call for done to be true, which is this with EX6 the iteration protocol in place. It is a workable consumer of data source of one value at a time and checking after each next call for done to be true to stop the iteration. But this approach is rather manual, so EX6 also includes several mechanisms, syntax, and APIs for standardized consumptions of this iteration. So, so yeah, so yeah, so yeah, so yeah. Basically, it's like yeah. So basically, it's like yeah. So one such mechanism is the for of loop, but now they have is okay. So in MX6, the iteration protocol is in place. All right. It defined now. It has now mechanism. All right. To automate the process of calling this function next. So this standard mechanism for consumptions, one of them is the for of loop, all right, where as long as this value is an iterable, as long as that value now has in the prototype or in the property is the symbol dot iterator, which these known symbols, and as we mentioned, symbols are used to hold values privately, and this private value is a reference to the iterator protocol. All right. So if this object is this value now implement, or if this value has a iterator, all right, has a reference to the iterator algorithm, it means that this is indeed a iterable. Mm-hmm. Or in other words, a value that can be iterated over. So we'll omit another mechanism that is often used for consuming iterator is the operator. Mm-hmm. This operator actually have two symmetrical forms, spread and rest, or gather as I prefer. Spread and rest or gather as I prefer. Mm-hmm. Makes a lot of sense. But again, it is describing is the this standardized mechanism, standardized standard mechanism for consumptions iterables, or for consuming these iterators, right? Mm-hmm. Whether it's the for of, and the other is this. Okay, in this operation actually has two symmetrical forms, the spread or the rest, or gather as I prefer. The spread form is an iterator consumer, where here you can define is now an statement. Yesterday we looked at how can we use this, by the way, and I do find that it's quite interesting, because here you can define is not only is expressions, right? Whether if these expressions are in the form of a how do I put it? Yeah, whether if this are expressed in assignments, all right, and this assignment is can be a conditional. I do think this is expression, by the way. I can take a look at that. Say Egma script here, and actually find that and say, hey, what is this no spread element, exactly, spread element assignment. Okay, assignment expression, and this assignment expression can be is with a conditional or a yield or an arrow function or an async arrow function or an assignment here like this, which is mind blowing here. So it expect also is a yield for that. So in other words, you can define it as not only a conditional expression, whether it's with and or double or conditional, like using the question mark, the ternary operator, or yield using now an iterator, all right, which means is that hey, I'm going to evaluate if this is an iterator yield expression, and the yield expression is this. Whether it's yielding a value, syntax context immediately follow yield require use of input elements, record or template lexical goal. Whether it's this, yield this assignment expression, all right, or yield is now the generator assignment expression. Now this is quite interesting. Static semantic early errors with generator methods. So if a syntax error if has direct super of generator method is true. So for example, this is when we talk about is this early errors. And in this early error is like, for example, you can have here in a function generator, say iterator gen, right? You can have here, for example, is the super class, right? And then you can add is this, say, hey, also log, say super gen, call, right? And then you call that. You say, you can have a super keyword unexpected here, This is the reason why JavaScript is indeed a parse language or compile language, right? So yeah, it turns out things like this. Mm-hmm. If it's a strict, okay, it's true, the early errors rules for unique formal parameters, and formal parameters are applied. If binding identifier is present and is a string is 0, okay, but this is the syntax error, right? All of this. But static semantics. But yeah, that's quite compelling. It's quite interesting. So we have now these two way of consuming iterators. Okay. All right. And a function call. Mm-hmm. And a function call. Mm-hmm. And a function call. All right. So this is another mechanism for consuming iterators, right? The spread's an iterator, an array spread, a function called spread, right? A spread an iterator into an array, which each iterated value occupying an array element position, which is this, and this is going to evaluate now this. it's going to evaluate now is this. It say, hey, with the spread element, as actually telling here, it say, hey, let me now figuring out if this object that I'm receiving, okay, is now an iterator. In other words, I'm going to look at that object that I receive and inspect for the methods that it has is the symbol async iterator, right? So the abstract operation get method takes argument v and so on and so forth. MP as it is, and return either a normal completion containing either a function object or undefined, or throw completion. It is used to get the value of specific property of an ECMAScript language value. So when the value of a property is expected to be a function, it performs the following step when called. So you get this. Function is either undefined or null and return undefined. If callable, function is false and throw a type error. But in other words, what it's doing is this. It's to say, hey, get v, get the value there. Okay, give me a second here, please. I'll be right back. And we're back with a different outfit, as you can see. Good. Now, here we are with get v, right? The abstract operation get v, text argument b. So what I'm looking here is at this. When the spread operator, which is a mechanism of how can we consume iterators, right? Okay, this is it's something that we can consume. Yeah, it's another mechanism for used to consuming iterators. Okay, for consuming iterators like this. So here the spread element is telling you this. You can put me an assignment expression, as I mentioned before, and then whatever value that I get here, I'm going to not only evaluate that value, I'm going to determine what value it is, this get value. This abstract operation that it is on here, ECMA specification type, okay? So you're going to get the abstract operation get value and takes the argument v, a record, which is a must be an ECMAScript value, all of these ECMAScript value that I mentioned, undefined, null, boolean, string, that is following is the UTF, or it can be is, and this is just to describe is the methods. You can have string likes index of, the symbol type, the well-known symbols, all right, the numeric type, all right, and all of the things that you can do with numeric things, as you can see here, via same values here to test value equality, ignoring the difference between 0 and minus negative. Okay, it's actually telling you this. Okay, that's interesting. As well as the number type. Okay, what is the number type here? And well, all of the operations that is going on when you do that. Interesting. All right, all of the operation and how these operations actually happens, right? So you look at all of this. Holy moly, bro. Even for the object.is, all right, object internals values via same value, even dot includes. Okay, so for example, if you do something like this, which actually match our intuition, you say includes is 1, you know, it give you now a boolean value here. Exactly, it return now a boolean value. here. That's built up intuition here. All right. Um, Binary bitwise operators and so on and so forth. If you want to coerce that, so the numeric, right, the number type, and all of the methods here, the big type, and all of the operation that we can do here, and the object type, right? And what the object type is made of, which is the value, the readable, the get and set, and enumerable and configurable. So this is very revealing, all right? And how now here, ECMAScript specification types. The specification type corresponds to meta values that are used within algorithm to describe the semantic of ECMAScript language construct and ECMAScript language type. These specification types include record, reference record, list, completion record, property descriptor, environment record, abstract closures, and data blocks. Interesting. So the enum type, so the set and the relationships. All right. Here's when we're starting to look at more other type, the reference record, the property descriptor, the environment record specification type, the abstract closure specification type. So closures, now let closure be the new abstract closure with parameter here. So you can also hail closures as values, all right, and the data blocks. So again, what is relevant for today, okay, is the following. So what is relevant for today is this. What it is. Is this one, right? So the spread element. So the spread element is say, hey, I'm going to evaluate if this is an assignment expression, as I mentioned before, and if that value, all right, and if that value, which is get value, is an abstract operation. Let's go to actually walk through this, shall we? I do find that this is something that might be quite tedious, but this is why we are here. Not for the tedious part, but for the understanding, please. Okay. So if we look at this and say, hey, this is the spread operator, and you say, hey, this is an assignment expression. This assignment expression is now defined as a conditional expression and or any of this short-circuiting expression, which can be interesting. It can be logical expressions or n expressions. Okay. So logical expressions. Okay. It can be a logical or expression, or a collision expression. Interesting. Okay. This short-circuiting expression. Okay. So this short-circuit expression, it can be either a logical or expression or a collision expression. And when you talk about collision, is that how now this particular value is going to be united, it's going to be merged into one. The term collision, unlike it involves is fusion, right? So the term collision involves is fusion. It says that two entities merge into one. Unlike yeah, because this is collision. collage, and the other is what? Like converge. So coalesce and converge, they have the same directions, but the end result is different. So uh, convey means to go into the same directions, but both of those entity remains the same, whereas coalesce is merging, involve a merging, involve a fusion. So this coalesce expression here is say, hey, you know what? We want is um, uh, collage this expression here, all right, by saying is, hey, this collage expression, which can be a collage expression in itself, or a bitwise OR operation, bitwise OR expression, whether it's this or this, all right, but it says that whatever the value, if you have a value, is going to take a look at this. Okay, if this value here is either undefined or null, right? Then I'm going to return whatever is on the right side, right? And return whatever is on the right side. If it's not, then return is whatever is on the left side. So this is actually helpful when it comes to evaluate is a kind of emptiness. If this value is empty, well, this will be now is the new value. If it's not, then go on and assign that value. So this is now the coalesce expression here, all right? Part of the short circuiting expression, logical OR expression, which can be this, all right? Which can be is a logical AND expression, and it can be a logical OR expression, all right? Which is quite interesting that it mentioned that logical OR expression, that it can be AND OR, okay? And this AND is this one or this one, and the subtle difference here is that this act like a gate, that if this is a true T value, then it's going to move on to the next one to be evaluated, and when it's evaluated, is going to now return this value. And now with logical say, hey, if this is now a falsy value, I'm going to return you that. If this is a true T value, I'm going to return you that. And I'm going to move to the next one. No, exactly. If this is now a falsy value, let me see if my intuition is right. So if this is now a falsy value, I'm gonna return you that. Okay, whatever value is this, okay. Look at exactly. It's going to coerce it express. Okay, because this logical coerce that expression. Okay, both of them coerce that expression. So if this return now a true T value, you're gonna return whatever is on the right. Okay, if this is a true T value, you're gonna return whatever is on that particular value. Exactly. You're going to return that particular value, and you're going to continue to evaluate the next one. Okay, this is part of the short circuiting. Okay. Okay, makes sense. So if this value, okay. This is why they know as short circuiting here, because n or it say, hey, the n say if this is a falsy value, all right, I'm gonna return that value. But if this is a true value, then I'm gonna open up the gates and return this value here. And if you have more values here, okay, so this is what it's gonna open up the gates, open up the gates, open up the gates. Whereas with OR, it say, hey, if this value is true, all right, I'm gonna return you that value. And if it's not, I'm gonna return to the next one, and the next one, and the next one. So both of them now act as a gateways, right? The N act as a gateway to check if that value exists, all right? And then it's going to go to the next one, and to the next one, and to the next one, all right? And the OR is going to return you that value if that exists first. If it's not, going to the next one, and going to the next one, and to the next one, and so on and so forth. Interesting. I do think that this is the confusion. This is where the confusion kicks in. So my confusion here is to say, hey, so the N, we're quite aware of what the N does, right? Because at the end of the day, N will say, hey, if this is a falsy value, I'm going to return that value. But for some reason, if that is a true T value, so let's go into, for once, for real, solve this problem, right? So anytime that we do is this, we want is to verify that we have those particular values, all right? And if we do, we want to return that value, okay? Exactly, see? And if we do, we want to return that value. All right, and if it's true, we want to return that specific value. So this is great for assigning is a set of possible values that this can have, all right, which is great. A set of possible values that this can have, whereas the conditional say, hey, as long as you pass through all of this series of gates, then I'm going to now give you this result. And that makes a lot of sense. As long as you pass all of these different gates, or all of those different challenge here, yeah, as long as you pass all of this different challenge, all right, then I can return that challenge complete, right? So even here we can create something like here, say function complete, right? And then print or say something like this, return this challenge complete, and then I'll call complete here, right? And it's going to evaluate that. So as long as all of these conditions now happens, then I'm going to return you is that. Mm. 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 Mm-hmm. Okay. So that's a good way of looking at this short circuiting. Okay. The end act as say, hey, as long as you pass through all of these different hoops, all of these different challenge, all right, then the last one is gonna be throw. I'm gonna return you is the last one, right? And it makes a lot of sense. And it makes a lot of sense. Whereas in OR you say, hey, I want you to provide all of this set of possible options here. All right, makes a lot of sense. So the end act like a gate, act like a hoping gates. All right, act like a like no okay act like the bouncer in the at the club. All right, they act as the bouncer at the club, the end gate. All right, whereas the or act like the possibility that you might have, right? All the possible things that you can have. Mm-hmm. Mm-hmm. Good. Good for this understanding. Good for this understanding. Whereas the correlation, it say, hey, um, I want to verify if a particular value is full, is a kind of emptiness, all right? And if it's not, then return that value. And if it is, so let return is the default value, for example, right? Okay. Okay. Makes a lot of sense. So this is now short-circuiting expression, and it makes a lot of sense. So we talk about this short-circuiting expression. It can be and, it can be or, it can be the coalition operator. All right. It can be also is short-circuiting expression with this with the ternary operator, followed by the assignment expression. And you get the assignment expression here, as it is. All right. Mm-hmm. And this is just to evaluate is the conditional expression. You can in the conditional expression you can have is short-circuiting expressions, short-circuiting assignment expressions, short-circuiting, and the ternary operator. So this is just to evaluate is the conditional expression. Okay, makes sense. So far so good. So we have the conditional expression. We also can yield using the generator or explicitly the yield keyword by saying, hey, you know what? And yield is 1, and it's a no, because it needs to be evaluated like this. No, unexpected number. Interesting. Perhaps do I need to evaluate this expression as it is? Nope. It's a yield expression. Nope, not at all. It's a hey, it can be yield. The syntax context immediately follow yield requires use of input elements or ranges of template tail. So in other words, yield no line termination here, and assignment expressions, which is this one. Okay. So it means that yield can be is in yield, unexpected string. Interesting. It doesn't accept that, but in fact it say, hey, I do accept this. So if this is true, return now true, or otherwise return now false. But again, it's going to return is unexpected token true. Yield expressions cannot be used within the formal parameter of a generator function because any expression that are part of the formal parameters are evaluated before the resulting generator in the resumable state. Abstract operations relations to generators are defined in 27 point here. And this is early error and error semantics. In the yield. In the yield, bro. Provide a couple examples of using the following text from ECMAScript with spread operator. Yield each element individually. All right. Yeah, but what about with Jill? What about with Jill? Exactly, but it's evaluating is each at a time. Exactly, you can also even evaluate as a conditional for this. You can say it's spread all of these elements, and then I want to now evaluate this, okay? And then I want to evaluate if the underlying expression here, okay? Okay, let's get into this. If this underlying expression here, or if this assignment, if this value that is producing, okay, if this value that is producing here is now exactly, so based on this condition, I want you to give me is now this, which is a spread on 7 and 8. So now this becomes is a new value of this complex, 7 and 8. And then you have a new one where you say, hey, but each one of them what it's going to is override that. It's like overriding that. Because it is spreading that. It is calling each one of them. Exactly. It's calling it each one of them element. And the same for this. It is calling this each one of them. And the same for this. Or is calling them each one of them, all right? But like stacking them. So in both cases, the iterator spread form of the following of the iterator consumption protocol, the same as the for of loop to retrieve all available values from an iterator and place, aka spread, then into receiving the context array and argument list. And iterables. The iterable consumption protocol is technically defined for consuming iterables. An iterable the iterator consumption protocol is technically defined for consuming iterables. An iterable is a value that can be iterated over. The protocol automatically creates an iterator instance for an iterable. Exactly. So hey, if this is an iterable, if this is an object that can be iterated over, okay? So the iterator consumption protocol is technically defined for consuming iterables, which is a contract here. So the protocol automatically creates an iterator instance from an iterable and consumes just that iterator instance to its completion. And consume that iterator instance to its completion. So in this case, it's going to consume that iterator instance to its completion. In this case, 4 and 5 and 6 by actually is calling each one of those files as long as this expression here, all right, as long as that assignment expression here produce now an iterable, right? The iterable, and if and the way how it determines that this is an iterator is by looking is at that, all right, is by looking is at that object, all right, and analyze analyze for this well-known symbol which holds a reference to this algorithm, iterator. Symbol iterator. So for example, when you create now an array in this form, all right, if this is so true, otherwise false. But I want you to evaluate this expression, and it say no. But if I want to inspect this and say, hey, but it lives inside of the prototype. Okay. So prototype. Okay. Type error undefined is not iterable. Cannot read property symbol and Symbol.iterator. So if you do have this, okay, Symbol.iterator, but it contains that. So under the prototype, another thing is to say, hey, is prototype of the Symbol.iterator? It'd say no. Quite interesting. Is true or false? Is not a function. Yeah, that's right. Cannot read property of undefined reading iterator. Yeah, you're right. Symbol. So the question is that how can I get is that this is a symbol iterator, you know? Because what I can do is to say, hey, if I want to get that, or if I want to determine if a particular value that I'm receiving here, let's say the function is iterable, right? Hey, it's because whatever value that I'm receiving here, okay, I want to determine if the value prototype, okay, contain is now the Symbol.iterator, right? If it is, return true. If it's not, return false. So with this simple example here, I can now call this an object and it say cannot read undefined is not iterable, cannot read property of Symbol.iterable. So it actually throwing a type error like this because it say, hey, no, it's not. In fact, this value that I'm getting is undefined, and because of that, I'm throwing is a type error here. Okay. Is throwing is a type error. So in other words, if you throw now an error, you say, hey, try and catch so try catch, right? try this, right? And I want you to evaluate this. And if you return some error here, I want you to return is false, right? Another way is return is the value it is, which is true. Return the value, just like that, you know? Because it's not defined there, then that's what will happen. So if I calls it say, hey, it's not throwing is the error, and in fact it say, no, this is false. So I'm not going to stop is the iteration of this. However, if I do pass now an iterable like this, it say this is false, which is not true. And the other is, hey, new set of unique values, 1 2 2 2 3. It's a number 1 is not an iterable. Oh, because it must be in this order. It must be in this order. It say this is false, all right? But the thing here is that it cannot detect is that that. So somehow it cannot detect that there, right? The other is that has own properties, okay? Or the other is that it's property of. I can ask if that has own properties to say, hey, Symbol.iterator, right? It say no, doesn't have that. So what about length? No, it's not part of that. Interesting. Okay. And the other is to find a way to look up for that. So it's prototype of. To revert to value of with on shift, and then you got is this. Property is enumerable, is prototype of, has own property include is prototype of, array is prototype of array. That's quite interesting to actually look at that. So it's by exploring is the prototype. I know that it's by exploring is a prototype, and trying to find that as it is, because I know this is what it is, man. But if I want to know, okay, this is a good question. How can I find is the prototype property? For example, how can I find the how can I find in the prototype chain, for example, in an array, to check for symbol, iterator. That's quite silly, bro. Because exactly, Exactly, because now in is not only going to look is at the own property, but also along the prototype change. So you can say something like this. Okay, all right. So we can do something like this. It's iterable, right? And say, hey, because this value is in the is this value in is this value is symbol dot iterator part of this value, right? And if it find it, okay, so that'll be true. If it's not, false, right? Pretty much like this. Pretty much like this. And then I want to return that. So for example, if I say this, it says, of course, this is not an iterable. But if I say something like an array, it say I'm going to look at the prototype chain and say, yes, it is. Or, not only this, but as a string, A, B, C, D, E, F, G, right? It say, hey, it's not here, which is kind of weird, that iterables, in fact, or that a string, or at least this kind of string doesn't have that, all right? Cannot use in operator to search for symbol, because this must be only is, okay, because this must be only is in only work, in operator. This is the relational operator, exactly, like in. It say, hey, if this is a relation, exactly, is this a relation, and this relation can be either all of this, whether it's a shift or additive expression. Okay, relational expression, an instance of private identifier, like this. Here, so when you evaluate is the in a relationship, it's gonna throw you a type error. If not an object, throw a type error, exactly. If error value is not an object, throw a type error, and that's what happens. So that's going to be evaluating as long as you pass here an object. All right. So it makes a lot of sense. So we can say here and ask, hey, if the value, so if the type of value is indeed an object, all right, then we can say, all right, so now I can actually investigate this one. All right. Yes, yes it is. Mm-hmm. 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 So if this is a type of value, all right, is an object, okay, let me actually verify that this is along the way in the prototype change. Okay. So if, for example, type of value is now a string, you can check if this and say, hey, this is a string, the value, all right. One safe way to do this might be is that it returns you now in a string as it is. Okay, you can say is, well, the string at the end of the day, they are iterables, just they are not aware that they are iterables. All right. I do want to find is the proto, all right, exactly, Symbol.iterator. But that's interesting because I will do have to find that through this, because the value that I'm passing here um, mm-hmm. If this is string, so then I want to return is now this value dot value true. As true. Numbers are not iterables, and that may be quite counterintuitive, right? So in other words, you can say is, if this is an iterable, all right, so I can now consume that iterable like this because I implement that. But numbers, what about numbers? Invalid unexpected token. What about value here? You say num comes here on the num 0, and you say num yeah, but I do want to find is the proto. Okay, that this does not have that. So this is how can we now is indeed create is now an iterable. All right, create now an iterable. So if this is an object, I want to figuring out if that object contains now that. If this is a string, it is. If this is a type of value is equal to number, this does not, right? Return false, right? If this is now a number, an undefined, or even bigint contains that, right? I'm assuming that bigint should be is now an iterable, right? For example, if you have this number, right, and you say this is something that I want to attach to bigint value, right? You say bigint value under the proto. At the end of the day, this is a string, so of course they do. Okay. All right. Interesting. So another thing that we can create here is this, and say, hey, if this is now type of value equal to bigint, right? So return now is true. All right. So for numbers, and so number is not, string it is, bigint it is, booleans are not, undefined and null as not, symbols is an iterable, right? That's a good question. those symbols contain that, and it's native code. So symbol it indeed doesn't have that, it seems so. So in other words, you can say is, well, this piece of code that we create here, otherwise now this is false, returned false. In any other cases, so you can say something like this, and a number like this, and if this, for example, returns something that is not a big int, right, something like this, it's just a string, it's true, as you can see here. But if this now is, for example, is a collection like this, alright, you see the label is an array, or a string, or an object, or if this is now a new map, alright, you're gonna define is, here is the values, you know, a new map, whatever it is, or a new set here to get unique values. So you're gonna get that as it is. So of course it's this one, and it's this one, and it's this one, of course, and it's set, of course, and so on and so forth, except for an object. And if you do pass a function here, right, it says now this is false. But if these functions return something, right, what about if these functions return something? Is going to evaluate the value that you're passing here, not the execution of that value. So in other words, you can say something like this, say, hey, so let make array, right? And here's how you can create now an array. This is a functions to create just an empty array. You know? You can say is empty array. And this function we're going to return you now is this, right? An empty array. I don't want to make this as an arrow function, not at all. I want to make this as an anonymous name function here, and then call is iterable here, and then pass the value, which is empty array to this, right? So this must say true, exact. But if you pass now a function definition, which is a reference, of course that is not. So all of this now give conclusion to how can we create now an iterator. What is how can we detect an iterator? What is an iterator at the end of the day? Okay, and as we do this, right? Exactly. As we do this iterator so as we do this, so what it's going to check is that contains now an iterator. All right. We also is now create now our own iterator. All right. To check that for us. So this abstract operation is looking and telling us to do this. And how can we determine that this is an iterator? And if this is an iterator, what it's going to do is to repeat that and call that until that is done. And create data property or throw. Create data property or throw. The abstract operation creates data property and takes arguments O, an object, property key, and the value here, and returns either a normal completion containing a boolean or throw completion. But at the end of the day, it's that. It's that, my friend. And it makes a lot of sense. And it makes a lot of sense. Absolutely. Absolutely. Yeah, it is, bro. So all of this just to talk about that, right? And how can we consume iterables? Whether it's by being the for of or by calling in the spread, and what the spread operator is doing here. Whether it's an array spread or a function call. In both cases, the iterator spread form of the follows. The iterator consumption protocol, the same for of loop, to retrieve all available value from an iterator, aka place, aka spread, then into receiving context, argue array, and argument list. And then the iterables. So what are the iterables? So any data structure that can be iterated over. And EX is defined the basic data structure collections like string, array, map, sets, and others, right? So since arrays are iterables, we can shallow copy an array using consumptions via the spread operators. But again, shallow copy. We can also iterate the character in a string one at a time. A map data structure uses object as key, associating a value of any type with that object. Map has different defaults iteration that seen here, in that the iteration is not just over the map value, but instead it is entries. An entry is a tuple, two elements array, including both the key and the value. Exactly, so map data structure use object as keys. Okay, use objects as key, associating a value of any type with that object. So map has different default iterations than seen here. In that iteration is not just over the map's value, but instead of it is entries. Okay, you can have now, unlike an object in map, you can have objects as key. An entry is a tuple of two elements array, including both the key and the value. And consider, given two elements, bottom 1 and bottom 2, var bottom names and bottom names dot set bottom 1s and bottom 2, all right, where here you define here as some variables or some objects. Exactly. So here you can hold is now objects here as reference. Okay. So maps allow us to hold reference as the key, unlike a string. And then we can now is with this reference have access to these objects here per context here. Holy moly. That'll be all for this video. Take care. Bye bye.